I'm Andrea Cerulli and I'm a senior researcher at Definity. And today I'm going to talk to you about how do we bootstrap the internet computer. Today I'm going to talk to you about how we bootstrap the internet computer so that it is decentralized, secure, and user can interact with it in an authentic way. But before jumping into this, let's recall what the internet computer is. The internet computer is a network of nodes hosted in independent data centers around the globe. Nodes are owned by node providers, which are members of the Internet Computer Association and are responsible to establish contracts with the data center and supply an agreed amount of nodes to the network. Nodes run the Internet Computer Protocol and are organized in subnets. Subnets are the computational processing units of the Internet Computer. Subnets can be added dynamically to the system, making the Internet Computer infinitely scalable. Within each subnet, nodes run a consensus protocol to agree on the next operation to execute. This protocol can tolerate a fraction of malicious nodes and faulty nodes, making the Internet Computer unstoppable. So subnets host canisters, which are software units that bundle together code and data, and that can be seen as an evolution of smart contracts that users can upload and install on the Internet Computer. Within the Internet Computers, there is a special subnet that hosts the network system. This is the governance system of the Internet Computer, and is formed by various canisters. These includes like the registry canister, which holds the system metadata that nodes need to use to operate the Internet Computer Protocol. Then there's the ledger canister, which stores the accounts and balances of ICP tokens. And lastly, there's the governance canister that implements the governance system. And neurons holders can use this canister to make proposals to the governance and vote on this. Proposals include operations like extending the capacity of the Internet Computer and upgrade the Internet Computer itself. As already mentioned, the Internet Computer is a decentralized network, and our goal is to make sure that this is true since Genesis. Once the Internet Computer is up and running, the DNS is responsible to govern it. So when it comes to decentralization, there are various aspects that one has to consider, including decentralization at the infrastructure level, decentralization at the protocol level, and at the governance level. So let's have a look what we mean by this. Decentralization at the infrastructure level means that nodes should come from many independent node providers around the world, and nodes should not be hosted in the same data center. They should also be distributed geographically. No entity needs to be in control of a large fraction of the network. Decentralization at the protocol level means that, for example, we want to prevent a single point of failure in the system, or that a malicious set of nodes can take over the Internet Computer. This is made possible by the use of threshold cryptography. Specifically, the protocol uses threshold signature, which allow nodes to jointly compute a digital signature even in the presence of a malicious set of nodes. For example, this is used to certify data on the Internet Computer. So if a user wants to access data authentically, he can get a certificate and verify these using a public key. Each subnet has its own public key, and the one that is held by the network nervous system subnet is used as a root of trust for the entire system. So it is crucial that all these keys are generated in a distributed way so that no entity can control them. So the last aspect of decentralization is governance, and we want the governance system to be open and decentralized, meaning that no single entity should be in control of the majority of the vote and in control of the decision made on the Internet Computer. So after Genesis, the network nervous system is in charge of the governance of the Internet Computer and can ensure that this remains decentralized. Therefore, it's crucial that its initial configuration at Genesis, the Internet Computer, is already decentralized. This involves two main aspects. One is the initial state of the Internet Computer, and one is how do we generate keys in a distributed way. Let's first have a look at what information will be included in the initial state of the Internet Computer. To operate the Internet Computer, we need to have the hardware that runs the node software, and this is supplied by node providers that register themselves with the Internet Computer Association. In the process, they generate some key pairs that they can later use to authenticate themselves with the Internet Computer. These interactions are registering new nodes and governing their own neuron. So each of these interactions has its own dedicated key. After Genesis, the registration of node providers can happen using the Internet Computer itself. But before then, we need to use an out-of-band mechanism between the node providers and the Internet Computer Association. Once the Internet Computer is started, the node providers can interact directly with the Internet Computer and check that their keys have been correctly registered. The registration key is used by node providers to register nodes to the Internet Computer. A dedicated key is used for this purpose so that node providers can delegate this operation to node operators in data center that can assist them with the operational steps. The public key is stored in the genesis state of the registry canister of the internet computer, while the secret key is generally stored on a hardware secure module and is used to certify the registration of a new node with the network. We also need to specify what's the genesis state of the governance canister, and this will consist of neurons that are initially controlled by the node providers, the Internet Computer Association, and the Definity Foundation. The initial configuration is set up in such a way that the Internet Computer Association and the Definity Foundation are not in control of the majority of the votes. Dedicated keys are used to manage these neurons, and after genesis, neuron holders can use these to check that their accounts have been set up properly. After genesis, token holders can also lock up their tokens into neurons and join the governance system. Lastly, we need to initialize the genesis state of the ledger canisters. This includes the initial accounts for all neurons holders, which includes node providers, Internet Computer Association, and Definity Foundation, plus all accounts for early contributors to the project and the financial investor who supported the project since its early day. So far, we discussed the initial state of the Internet computer at genesis. What remains to show is how we generate the root public key and how we bootstrap the Internet computer. The root key is generated in a decentralized way using a new distributed key generation protocol that we developed. In our distributed key generation protocol, we have a set of nodes acting as dealers that encrypt key shares for the receivers. These shares are encrypted using a novel forward-secure encryption scheme. Each dealing comes with a zero-knowledge proof attached, attesting the validity of the encrypted share. This allows the protocol to be non-interactive, meaning that the receivers do not need to be present during the execution of the protocol. Invalid dealings are simply discarded. Once sufficiently many valid dealings are collected, these are combined to derive a common threshold public key. The recipients can decrypt their own shares and construct their own secret signature key. For the protocol to be secure, we only need to assume that there is at least one honest dealer in the protocol. This guarantees that the keys contain sufficient entropy to compute threshold signatures that are unforgeable. The distributed key generation protocol is run as part of the normal operation of the Internet computer. This is, for example, run when we add a subnetwork to the system or we need to allow new nodes to participate to the Internet computer protocol. This is also used to self-bootstrap the Internet computer starting from a centralized instance. And we can now see how we're going to do that. We start the bootstrapping process by initializing an auxiliary subnet. This is a subnet that we only use for the purpose of starting the network system of the Internet computer, and then we can discard this. This auxiliary subnet consists of a single node running on a single data center. This subnet, as any other real subnet, has also a threshold key. However, since there is only one node in the subnet, the threshold is equal to 1, so the node is in complete control of the key. We also install some canisters on this auxiliary subnet. We install an auxiliary registry and a governance canister. The auxiliary registry is initialized with identities of the node provider contributors to the Genesis network. This registry also stores the root key of this auxiliary network, which is the same as the public key of the auxiliary subnet. The governance canister is initialized in such a way that there is only one neuron in control of the proposal and voting mechanism, and this neuron is held by the foundation. At this point, the network doesn't have any of the decentralization properties that we want. The node is operated on a single data center and controlled by a single node provider. The root public key is not generated in a decentralized way, and the voting mechanism is centralized and controlled by a single entity. We now go layer by layer and see how can we use features of the Internet Computer Protocol to make the Internet Computer decentralized. First, we add more nodes from independent data center. Since the registry contains the identities of the node provider, this can add nodes to the auxiliary network. This is done by installing node software on machine hosted in the data center and using an HSM to certify the first interaction of the node with the network. During the registration, each node generates some keys. The secret keys are stored on the node, while the public keys are stored in the registry. So nodes are initially added as free nodes, meaning that they are not yet assigned to any subnet. The governance system can then assign these nodes to either an existing subnet or to create a new one. In the bootstrapping process, the Definity Foundation then assigns nodes to the auxiliary subnet. This is done by making a proposal to the governance canister. Once the proposal is accepted and executed by the governance canister, the nodes can join the subnet. At this point, the auxiliary subnet is composed by nodes coming from separate data center and node providers. However, the key used to certify information on the subnet is still the same, meaning that it cannot be fully trusted. To generate a trusted key for the Internet computer, we can simply instruct the governance to create a new subnet. As soon as the proposal to create a new subnet is accepted, nodes on the auxiliary subnet will start running the distributed key generation protocol, generating keys for the new subnet in a secure and decentralized way. All nodes in the auxiliary subnet participate as dealers in the distributed key generation protocol, meaning that we only need to trust a single node provider to participate honestly in the protocol to ensure the keys are secure. Once the new key shares are created, the nodes join the subnet and start operating the internet-to-computer protocol. At this point, this subnet consists of nodes coming from independent node providers, and there's a key that is generated in a distributed fashion and is secure to use. We now have a network that is both decentralized at an infrastructure level and at a protocol level. For this network to be fully decentralized, it only remains to establish a decentralized governance. This is done by installing DNS canister in it. Canisters are installed on DNS using the initial genesis state, meaning that the registry contains the keys of the initial node providers, and has the key of the DNS subnet as the root key. The governance and ledger canisters are also initialized with accounts as prescribed by the genesis state. Now, DNS is fully decentralized. It is formed by nodes coming from independent data centers and node providers. It has a root key that is generated in a distributed and secure way, and has decentralized governance. Moreover, the internet computer is now autonomous and self-governed by DNS. The governance system can then extend the capacity of the internet computer to scale infinitely. As I showed, the advanced technology that we introduced makes it possible for the internet computer to be easily bootstrapped without introducing additional complexity and by using the protocol itself, starting from a centralized network to a fully decentralized one.